Hello everyone, I am Hans Christian and these are my preliminary results for the project. First, I'd like to give a quick recap of what I'm working on. Basically, I want to see how difficult it is to make some kind of program that will generate data in such a way that it would be hard to spot the difference between it and a user using a web browser. So I will capture packet data using a packet analyzer known as Wireshark, and then based on this analysis can I distinguish the two. So the first thing I had to do in order to test all of this was to make a viable test protocol that allowed me to get relatively consistent results. I have used two different web browsers, Mozilla Firefox and Internet Explorer, but I've mainly been focused on Mozilla Firefox. These browsers store a great deal of temporary data for each visit. So in order to make each session as clear as possible, I run them in private browsing mode, I disable cookies, and I also have no add-ons installed, so no Flash Player or AdBlock or stuff like that. I must also make sure that the page is fully loaded. Sometimes web browsers will delay downloading the content that is not shown on the page, so I scroll the window or I scroll the page up and down to make sure that everything gets loaded. So when capturing the data, I have configured Wireshark to operate in non-promiscuous mode. A web page typically consists of content that comes from several different web servers. So to make things a bit simpler, I've focused only on the IP address that corresponds directly with the IP address given as answer to the DNS request. So for Vega, it is a specific address, although Vega has content spread over several other IP addresses. So when writing the software, I write it in C# and I use a net framework class known as web client to download the content. So I will refer to the program as web client in the future, just to distinguish it from Firefox. So the first attempt was a very simple one-line program that visits Vega, and then I will capture the traffic with Wireshark and compare it with the data captured from Firefox that visit the same page. So of course I did not expect that this simple first attempt would match Firefox data completely, but I use it as a starting point for developing the web client program further. So as can be seen from this picture, the two captures have a very different packet length on the initial get command, and there's also several additional get requests performed to get additional content. To see why these packet lengths are so different, one can open the packets in Wireshark and then look at the get requests in detail. What can be seen is that Firefox has several additional headers, while the web client only has the bare minimum of headers. So the web client needs to be expanded to also use these additional headers. So based on the packet capture from Mozilla Firefox, I would need to expand upon the web client program so that it matches the data captured by Firefox. So the first thing that must be in place is to see that the web client retrieves all the content of the page. This is relatively easy to implement. It also needs to have the matching headers when performing the GET request. And this proved to be a bit harder than I expected. So some headers are relatively uncomplicated, such as the user agent header, which provides the browser name and version. This header appears in every GET request and is always the same, and it's very easy to add it to the web client. Some headers can be more tricky to add, and some varies depending upon the content that is downloaded. So for example, if you're downloading a picture, then the headers will reflect that, and if you're downloading just text, the headers will reflect that. So some headers are the same, but some headers will be different depending upon the GET request. So after a bit of work, I was able to figure out all these problems and was successful in adding all the headers so that they would match Mozilla Firefox's headers. So as you can see in this picture, they do perform exactly the same requests. So then the question was, given that the requests are exactly the same, would the rest of the traffic match as well? So although it's still early to say yet, based on the statistical analysis performed in Wireshark and the manual analysis I have done, these captured data do not seem to be similar at all, except for the GET requests. So I have to perform some additional tests and analyze the captured data further in order to conclude something definite. And this is something that I will focus on the next coming weeks. So something I also been working on is trying to figure out what features are useful for distinguishing between the web client and Firefox. And it seems that packet length could be a good way of distinguishing between the two. I conducted a simple experiment where I compared the packet length from captures done on Internet Explorer and Mozilla Firefox on 15 different web pages. And I found that the average packet size in Internet Explorer will always be smaller than the average packet size in Mozilla Firefox. The average packet size from the web client and the Firefox dumps are also quite different. So this feature might be a good feature to distinguish the two. Another problem I also have been figuring out is that I spent some time finding out which format should be used for storing the data. The data should be stored in such a format that the program should be able to easily read the data to perform, for example, cluster analysis. Wireshark allows for storing capture dumps in several formats, but also allows for exporting packet data in several formats as well. The exported format will not have all the data, but I found that exporting data to a CSV format provided the easiest access to the data, and it had all the features that I needed. So that just about covers what I've done up till now. So next I will get started on generating more test data samples and then analyze them to see if there's a clear pattern. I want to finish with writing the report by the 23rd, as I would also like some time to focus exclusively on the digital forensics project. So this is where I'm at today, and this concludes my presentation.